Yeah, that's the good thing about module federation. It allows me to do a lot of Star Trek memes because, you know, the United Federation of Planets and module federation. So once again, thanks for the invitation. It's really a pleasure to be here. This will be about module federation as mentioned before, and I want to start with a picture. Perhaps you remember this woman. I'm not sure if this TV show was also sent out in your country, but I guess because it was quite a famous TV show. The TV show was called Knight Rider, and this woman was Bonnie. She was the engineer on the Knight Rider team. It was an 80s TV show, you know, and back then she fixed all the issues of the Knight Rider team. She was an electronical engineer, but also the computer scientist. And she really inspired me to buy a computer or to make my parents to buy me a computer. I've told them, hey, parents, you know, it could be beneficial for school, which was not really true, but it was also not really that wrong. So they bought me a computer. But one thing is quite funny when I'm thinking back to Bonnie, namely she was a one-woman show. She was the only engineer on the team and she was capable of doing everything. And nowadays that's not possible anymore because nowadays computer science and especially, let's say, software engineering is a team sport. You need to have several people, several roles, several skills. And so you need to find a way to work together with other people. And besides this, very often it is not only just about one team, very often it is about coordinating several teams. You have an away team, you have the bridge team, you have the team in engineering when it comes to Star Trek, and you have to coordinate all of them. And while coordinating one team is difficult enough, coordinating several teams is really, really hard. So the big question is, how can we do this? And the answer is, don't write a monolith. This answer has been around for about 20 years, I guess. Don't write a monolith. A monolith is a big application capable of everything. Cooking your coffee, cooking your main dish, and booking some flights, for instance. This is too much. Instead of this, you should go with several tiny systems. In the backend, we are calling those systems microservices for some years. That means in our case, we would go with a booking service, with a check-in service, with a luggage service, and perhaps a boarding service. And the less they know about each other, the better it is. Because if they don't know anything about each other, you can change one system without interfering with another system. You can implement an update here without breaking something there. So in an ideal world, those services don't know anything about each other. In this world, there are some interfaces. The lesser, the better. Yeah, they are really isolated from each other. And because they are isolated from each other, you can assign individual teams to them. In terms of domain-driven design, which is quite an old but still a valid methodology, those microservices are called subdomains. A subdomain is just a part of your business which don't need to know much about other teams. And so you can create own services, own applications for those parts. If we take this idea of microservices and put it into the front end, we have something like Microfrontends, which is just about having simple applications, simple single-page applications per domain. So the big question is now how to implement microfrontends. And well, it was always possible, but you need to use some tricks in the past. Some dirty tricks like manual tool manipulations, for instance. That was not that nice. And also we are not used to things like this anymore because we are used to going with frameworks like Angular, don't we? So every time I showed those tricks to load several applications into one big overall applications, people looked at me as I would eat little children. And so you can imagine that was not that funny. But the good message is now we have a really rock solid foundation and a rock solid solution for building micro frontends. It's called Module Federation, and it will arrive with Webpack 5 in some weeks. And yeah, this is what this talk is about. I will show you how to use Module Federation together with Angular to build micro frontends. Regarding the contents, first of all, I want to talk about consequences of micro frontends. As everything, micro frontends are not a free lunch. You have some advantages, but also some disadvantages. And before concentrating on the techniques, we should be aware of them. Then I will talk about Module Federation. I will show you how it works and why it is a rock solid, beautiful, clean solution. I will go on with dynamic module federation, and we will talk about version mismatches. What's when we have Angular 9 in one micro frontend and Angular version 10 in the second micro frontend, and what's if we try to use both together in the same browser window. Also, I will give you a possible roadmap. Hopefully you will like the idea of module federation, and then your next question would be, well, when can I have it? And for this I have this number 5, this point number 5. I will show you when you will very likely can use it. So before we start, let me also introduce myself. I am Manfred. I am a trainer and consultant for Angular. I'm doing a lot of remote workshops nowadays because of the current situation, you know, and I'm also doing remote consultancy. My current product is a workshop about Angular in the enterprise. It consists of a lot of advanced stuff that are not in the handbook, stuff you need when building big enterprise solutions with Angular. And besides this, I'm quite connected to the Angular community. I'm part of the GTE program for Angular, and I'm a collaborator in the Angular team. Perhaps a funny story about the term collaborator. You know, I live in Austria, and in Austria we speak German. And in German, there is also the word collaborator. And it means almost the same, but always in a negative way. So it's very funny when I'm telling someone that I'm collaborating. What are you doing? Don't destroy Angular. Because in German, collaborating means teaming up with other people to destroy something. Well, and if you look into my first pull request, it was more of the German meaning. Meanwhile, hopefully, I've reached the English meaning of collaborating. Saying this, I live in Austria, I'm doing a lot of stuff in Germany, and I'm always happy when I can work together with people in other countries, because it's really nice to meet other people, and nowadays, because of the current pandemic, it is easy because we have to do remote like now, so it's easier than before. Okay, so let's get started with the first part of this presentation. Let's get started with consequences of micro frontends. Nothing is a free lunch nowadays. Well, I think the biggest advantage of going with micro frontends is that we have a lot of decoupled frontends. Then we can assign one theme to each frontend. That means one team can work on that front end without interfering with other teams. We cannot block other teams, we cannot be blocked by others, and we don't need all those big meetings. When we are done, we just deploy it and everyone will get our new features. We don't need to coordinate that much with others, which brings back a lot of agility even in big projects. And this comes with a lot of further advantages, like we can have a separate deployment, but also a separate development. When we are done, we deploy it and we immediately provide additional business value, as Scrum and other agile methods are saying. We can also do our own architecture decisions as well as our own technology decisions. Not each and every architecture fits for each and every domain. And also when it comes to technologies, we don't want to stick with our technologies we are choosing today. Perhaps in 7 years, there are better technologies for the domains we have to implement them. So this is not an advantage for the short time, because in short term, we don't want to mix and match all the frameworks available out there. We don't want to have a framework zoo, but in mid and long term, it's beneficial, because in mid and long term, we want perhaps to migrate away to another technology. And especially when it comes to enterprise software development, this is vital, because an enterprise software is developed for years or for decades. Saying this, as you can see by the advantages I've shown you, this all is first and foremost about scaling teams. It is really about scaling teams. And a good friend of mine told me, teams is plural. That means you need to have more than one to have teams. And that tells us that if you only have one team, this is most likely an overkill. Well, there is an exception to each and every rule, of course, but in most cases it would be an overkill, because there are some disadvantages you have to deal with. Let me talk about those disadvantages, about those challenges. One challenge is you have to concentrate on UI composition. That means you have several loosely coupled micro frontends, but you have to present them to the user as one big thing. The user is not interested into starting 50 micro frontends each and every morning. We are happy about this, because that means 50 less complex, tiny pieces of software. The user is not interested. They want to have a big application capable of everything they need. So we have to compose them. We have to present all those tiny micro frontends as a common thing. UI consistency is also a big thing. It would be bad if one part of our system, one micro frontend, needed a save button to be clicked, and another part of the system would have an autosave functionality. Or we have this design here and another design there. It's not a consistent look and feel, and this is not creating, let's say, trust. Also, bundle size is an issue, because you really want to avoid to load Angular 10 times if you have 10 micro frontends. Somehow you want to share dependencies. And when sharing dependencies, you have to deal with version conflicts. What if one micro frontend has Angular 9 and the other one has Angular 10? And both of them are loaded into the same browser window. Somehow we have to make sure that not all hell breaks loose. And there are some additional challenges, but for the time being, let's stick with those 4. They are enough for us. Well, I have a good message for you. Module federation, which I'm talking today about, is solving most of those issues, more than the half. It is solving UI composition. It is solving the bundle size issue by allowing you to share dependencies, and it gives you some strategies to deal with version conflicts. Those strategies are great, and if you ask me, those strategies is all we can do within a framework. Perhaps it's not all you need. Perhaps you need some additional measurements, like, let's say, like some conventions or like some company internal policies. Okay, so that's a really great solution, and it really helps with all those downsides. When it comes to UI consistency, you should really look into design systems. Saying this, let's move to the second part of this presentation. Let's talk about module federation. Webpack 5 module federation. And I'm always saying module federation is a bit like the 1980s. You have to experience them, otherwise you cannot understand them. And so I'm starting with a demonstration here. Let me switch into my browser. What you see here is what I'm calling a shell application. A shell application is capable of loading microfrontends on demand. For instance, when clicking here, I'm loading an Angular-based microfrontend. It's the microfrontend with the red dashes, with the red dashed border. And this microfrontend also runs in standalone mode, as you see here. So it is really a separate application. It can be developed in separation, it can be deployed in separation, and when it's deployed, the shell will just load the newest or a configured version of it. When we look at the Chrome tools, at the network tools, clicking here looks a bit like lazy loading, doesn't it? I'm clicking here and I'm getting loaded this bundle here, 798. A very self-describing name, if you ask me. No, that's just typically for a production build. I just did the production build for this, and so I've got an ID as the name, but that can be configured. The best thing about this bundle is it only has 3.1 case, which is literally nothing. It's really nothing. And this proves that my microfrontend does not come with its own version of Angular. It is just reusing the Angular version loaded into the shell. This calls for very tiny bundles. Perhaps you're saying now, come on, Manfred. Come on, Manfred. This is just lazy loading. We have this for years. No, I'm saying this is more than lazy loading. You can see the difference by looking here at the origin. It's HTTP localhost 3000. And when we look here above, this is localhost 5000. So it's a completely different origin, and that has not been possible with lazy loading before. We are loading something from over there from a completely different origin, just on demand in the middle of our application. So the big question to understand what is happening here is how to load separately compiled code from this other origin. And perhaps you're saying now one more time, come on, Manfred, we have this dynamic import, don't we? So why don't use dynamic ECMAScript imports to point to another location? And even before we had dynamic imports, we could have used require. You know, in CommonJS, in Node.js, we have this require. Well, the thing is, in theory, this works. But in practice, when we are using Webpack, this does not work. And nowadays, almost everyone is using Webpack, especially in the world of Angular, because the CLI is heavily making use of Webpack. Also, other areas like the React area or the Vue area are going with Webpack. So this does not work. And the reason is Webpack assumes that everything, really everything, even the lazy parts, are known at compile time. Everything needs to be known at compile time because everything is optimized together. Tree shaking, minification, and so on. And then the rest is just subdivided into chunks by Webpack. At the end, it is creating chunks that can be lazy loaded, but only at the end. So first of all, everything needs to be known, and that's why this does not work with separately compiled and deployed application. But Webpack is changing this with a very easy way. We don't have to do much. Everything we need to know is that Webpack 5 module federation has two roles. The first role is called the host. The second role is called the remote. In my case, the host is the shell and the remote is the microfrontend. And now we can configure the host by mapping URLs. We can define, hey, Webpack, everything that starts with this URL points to another origin. We could inform Webpack about this origin here, about this very location. We can also provide this location on application start. I'm doing the later one. I'm just saying, hey, MFE1 stands for Microfrontend 1. Very creative, I know. MFE1 points to another origin. And by the way, over there, it's also called MFE1. I could define an alias here. I could say what's called Manfred here is called Batman over there. But here, I'm not making use of this. Also over there, within the configuration of the remote of the microfrontend, we can expose stuff. We can expose files with, let's say, Ivy components or Angular modules. Here, I'm just exposing an Ivy component. I'm saying, hey, everything within that file is exposed under CMB. And then something beautiful happens. I guarantee you, something beautiful happens. You can use a dynamic import, and this dynamic import now points to your mapped path, to your mapped URL, and this mapped URL in turn points over there where we can grab this CMB stuff. This is all we need to do to load something from the middle of another application. That means Angular itself does not even notice. Angular itself is just executing this import statement, and everything is done by Webpack underneath, which is quite beautiful. Of course, we need to tell the shell about the URL of the microfrontend. And for this, we have several possibilities. As mentioned before, you can hard code it in the configuration of the shell, but you can also define it on application start. On application start, we can namely load a so-called remote entry point from the microfrontend into the shell. For instance, by going with a script tag. The remote entry point is just a tiny file. It is automatically created by the microfrontend when it's compiled by Webpack. Just a tiny amount of bytes. Not even worth mentioning that it needs to be loaded. It's really tiny. And when we load this remote entry point into the shell, Webpack's Runtime API knows everything about handling this remote. It knows everything about loading this remote, the rest of it on demand. There are also other ways to do this. You can create a dynamic script tag, or you could even use an API call to load this script here, or to define the location of the remote entry point. It can also be done dynamically. So you can also share libs. You just need to put the libs you want to share into the configuration of the shell and the microfrontend. In this case, I'm sharing Angular core. That means the microfrontend would not come with its own Angular core. It would reuse the Angular core loaded by the shell. This was what we have seen before, and it's really that simple. Okay, now let's have a look at a demonstration that shows us how this all works at runtime. For this, let me switch back to my example. And if we look into my example, we see this routing configuration. This is the routing configuration of the shell. And as you see here, I'm just doing lazy loading. From Angular's perspective, this is just lazy loading. Load children with a dynamic import. But Angular does not know that underneath the covers, this URL is mapped to something over there. This mapping happens in the world of Webpack, and so Webpack would load this lazy module on demand from this other origin. To make Webpack doing this, we need a Webpack configuration. It looks like this here. This Webpack configuration is just telling Webpack that we have a remote called MFE1. And it's also called MFE1 over there. And it is telling Webpack that we want to share this and that libraries. This is the configuration for the shell. The rest here I also did by hand, but normally the rest here is done by the Angular CLI. Unfortunately, we don't have CLI support for this yet, and so I just hand wrote the whole configuration. But in the future, you only need to write those few lines of configuration code. The rest will come from the CLI. So this is the configuration in the shell. When we move downwards to the configuration of the remote, of the microfrontend, we see more or less the same here. I'm assigning a name to this microfrontend. I'm defining the name of the remote entry point. I'm exposing an IV component and a module, and I am defining that I want to share some libraries. And that's it. Now I only need to compile everything with Webpack, and this allows me to load the microfrontend into the shell at runtime. Well, of course, to tell the microfrontend shell about the microfrontend, I need to load this remote entry point from the other location. Just a tiny amount of bytes as mentioned before. Alternatively, you could go with a function call. Here I just called this function doit Webpack. It is just a pseudo function which would call the Webpack runtime API underneath, or you could hard code this location in the shell's configuration. Yeah, that's everything you need to do. And I say it one more time, Angular is not even aware of that you are going with several microfrontends. Okay, great. So we have a plenty of time I've seen, so let's also talk about dynamic module federation. The current version of module federation is assuming that all the microfrontends are known at startup, at the startup of the application, at the startup of the shell. But you can even go one step further. You can load everything just on demand dynamically, which is what I'm calling dynamic module federation. When you go with dynamic module federation, your shell does not need to know the remotes upfront. You don't need to configure them when you compile your shell. Besides this, you just use a tiny helper function that is loading everything on demand, everything when you need it. And for doing this, you need to provide free corner data to your function. Namely the remote entry point from over there, the name of the microfrontend of the remote over there, and the name of the exposed file, the exposed IV component, the exposed module. It's really not more. And then just on demand, Webpack would load those stuff with its runtime API and return it to you. As mentioned, this is just a helper function, and it is dealing with the not that beautiful Webpack runtime API underneath. Okay. Let me show you a demonstration for this. In this demonstration, I will move to another example. Yeah, here we go. And this other example also has a shell at location 5000. And it also is capable of loading other stuff on demand into its working area. You see it here, we have a red microfrontend, we have a blue microfrontend. But the thing is that this shell does not know upfront about our microfrontends. When the application is started, it gets some master data from a configuration service in the backend. And this master data is saying, hey, we have something, please display it under the name flights. On demand, you find its remote entry point here. It is called that over there, and the exposed module is also called module. And by the way, we also have something which you have to call bookings in your application. And if you need it, load it from this remote entry point. It is called Microfrontend 2 over there. And the exposed module is also called module over there. So I'm really doing this on demand in a very, very dynamic way. You can also use this mechanism to create plug-in systems. This is what I'm doing in my third example. Let me start this example too. What I'm having here, a plug-in based workflow designer. It allows me to drop some workflow tasks to my working area. And the best thing about this is that those workflow tasks are not hard-coded in the workflow designer. They are loaded on demand. For instance, there is a micro front-end on localhost 3000 providing the upload and the download task. And there is another micro front-end on the location localhost 3001, and it provides the analyze and enrich task. And one more time, when this workflow designer starts, it gets some metadata from the backend. The backend is telling it, hey, we have at this location the download task, and at the same location the upload task, and at another location analyze and enrich. And the workflow designer is just saying, okay, cool, I'm taking it, and then it will just use those items, those actions. It will provide hyperlinks for those actions so I can add them to my workflow. Very dynamic. Everything is just known on demand. Everything is known on runtime, not on compiler. So I think you see here, module federation gives you a lot of new possibilities, a lot of possibilities you did not have before. Perhaps you're saying now, yeah, this is nice. I can do it statically or even dynamically. I can load other stuff into my shell. But what's with version mismatches? What's if I have Angular 9 here and Angular 10 there? Well, the thing is, module federation can very nicely deal with such situations. By default, it is using semantic versioning. That means if we have Angular 10 here and Angular 10.1 there, it is choosing for Angular 10.1. So it looks which libraries are provided by the shell and the micro frontend, and by default it is using semver, semantic versioning. It takes the highest compatible version. And you know, as version 10 and version 10.1 are compatible, it goes with version 10.1. That works quite nicely, and this only works because there is a negotiation. There is a negotiation when the application starts. During this negotiation, the shell says, I have this, all the micro frontends say, I have that, and then decide together which version to use. Of course, this only works nicely if we only have compatible versions. If the shell and all the remotes can offer compatible versions. If they are not compatible, each micro frontend can fall back to its own version. That means the shell has Angular 9, the micro frontend comes with Angular 10. In this case, we will get both versions loaded into our application. The shell would use 9, micro frontend would fall back to version 10. This is the default behavior. You get this behavior without the need to configure anything. If you don't like this behavior, you can relax the accepted version ranges. For instance, your micro frontend could say, well, ideally, I would get Angular 10, but I also work with Angular 9 because between version 9 and 10, not much changed. Yeah, it was a new major version, Angular 10, but honestly, it was more of a maintenance version. And so it should be more or less be backwards compatible to version 9. So you can just relax the accepted versions. It's just a matter of configuration. Or you could configure a singleton. You could say, no, if there are two non-compatible versions, I will emit a warning on runtime, or you could even make it to emit an error, fail fast. We are failing immediately when the application starts because we find out that we have a version mismatch. This is called a singleton, which means we are only allowed to load one single version of your framework. Honestly, this makes the most sense, the singleton, when you have a big leading framework like Angular, a big leading framework which is holding some state. If you have a tiny stateless library, falling back to an own version or relaxing the accepted version ranges could be just fine. Think about RxJS or underscore or Lodash. In this case, it might be okay to fall back to another version or to go with another version you have not tested your part with. But when it comes to Angular, you will very likely go with a singleton. How can you configure this? Well, that's not that difficult. In this case, don't provide a shared array. Instead of your shared array, provide a shared hash map, a shared object. Here you have the names of your libraries, and then you can define that this library is a singleton and that you want to have an error when there is an incompatible version for your singleton. By default, you just get a warning. By setting this to false, you get a warning. By setting strict version to true, you get, ouch, an error. Sometimes it's better to fail fast. And this is how you can relax the required version. You can say, well, normally I need version 10, but I know I can also work with everything between version 1.1 and everything that is lower than 11.1.1. That's possible, just provide a Boolean expression. Okay, that's really nice if you ask me, because it solves a lot of those issues you have when it comes to providing separated compiled stuff that needs to be loaded in your shell at runtime. And hopefully you are now as excited as I am. And so the big question is, when can we have it? Well, the answer is currently Webpack 5 is in beta. It will turn into our C phase, into a release candidate in the next days. The release candidate is due, and after it is a release candidate, it will last about a month. After this month, we can have the final version. This is typical for the Webpack team. They don't wait a long time. When it is RC, it will become final very soon after. That means we will get Webpack 5 in a final version very soon. That's not the issue. But we also need an integration into Angular. To make it work with my examples, I'm using, and please don't do this at home, a patched version of the CLI. I've downloaded the source code of the CLI. I've downloaded an experimental batch of the CLI team. I've squeezed it into the source code and I've compiled it. So this is not the right way to go for production ready software, but it helped me to show you what will be possible in 1 or 2 months. And I also had to write a Webpack configuration by myself, which is also not the fine English way of doing things. You know, when it comes to Angular, we have the Angular CLI, and the Angular CLI is providing the Webpack configuration. We don't see it. It is created and used underneath the covers. So what we really need is Angular CLI support for Webpack 5. And here we might be lucky. I cannot promise it, but we might be lucky, because the next time window for the next CLI version is late fall 2020. In the last years, it was late November or early December. And yeah, then we will have version 11, and hopefully they will incorporate Webpack 5 into version 11. If time permits, they will do it for sure, because this is how the Angular team is working. They always try to incorporate the latest stuff, like, you know, the latest Webpack version, the latest TypeScript version, if time permits. If time does not permit, I'm pretty sure we will get Webpack 5 support with version 12, and version 12 will be due in spring 2021. This way or that way, it will not be a long time until we can have it, especially if you write an enterprise-style application. You can just start now, and you can be sure that in some months you can use all of this goodness. Of course, we need to find a way to squeeze the module federation config into the Webpack configuration. The Webpack configuration is created by the Angular CLI. We have our module federation configuration, and we need to squeeze it in. For this, you can enhance the CLI by providing a custom builder. There are a lot of custom builders out there. For instance, I wrote ng-xbuild plus, which is capable of this. ng-xbuild plus is nothing else than an extension, a builder. The core has about 5 lines of code, and then there is some additional code for the ceremony you need to make it work together with the CLI. And those 5 lines of code are just squeezing a partial Webpack config into the CLI's Webpack config. So after the CLI supports Webpack 5, we are on the safe side. Okay, if you like this idea and if you like this presentation, please check out my ebook about this. It's a free ebook, and I've written down everything I've told you now and even some additional stuff. And if you don't like this talk, download my ebook anyway. Perhaps I'm better with writing than with speaking. Who knows? Okay, let me come to a conclusion. We have seen the main purpose of all of this is scaling teams. That means you need to have more than one team to make sense out of this. More than one internal team or more than one external teams providing things like tasks for your workflow system. It's about decoupling, not only decoupling software products, but also about decoupling teams. They shall work in isolation so that they don't influence each other, so that they don't slow down each other, so that they don't need to participate in all those boring meetings. Module federation is about importing stuff from over there. It also allows you to share libraries, and it has a lot of strategies to deal with version mismatches. And you need to take care of conflicts, because if you have bad luck at runtime, Angular 9 and Angular 10 meets each other, and then all hell might break loose. And if you don't want to do this, of course, you can configure singletons in module federation. But in addition, it would be nice if you had some conventions preventing this situation from the beginning. Conventions which are telling you, hey, everyone has to use Angular 10 now, or conventions that are checking using, let's say, end-to-end tests if everything works together after deployment. You need to deal a bit with testing, a bit with conventions to make sure everything works seamlessly together when it meets for the first time at runtime. There is a last thing I want you to remember. It's about Bunny. I started with Bunny and I will finish with Bunny. Please try to be a bit more like Bunny, because Bunny was always thinking first. Instead of her counterpart in this TV show, he was always hitting first, this guy who was looking for freedom. But Bunny was always thinking first. And what I want to say with this is please first of all evaluate if micro-frontends are the right solution for you. If you say no, it's not the right solution, then go with a majestic monolith, which means a very beautiful monolith with a beautiful architecture. An architecture making sure that not each and every part of the system is talking with each and every other part. And if you say, no, I need micro frontends because I need a separate deployment, I need a separate development, I need to coordinate several teams, then consider module federation. Module federation would be a very beautiful solution for all or at least most your needs when going with micro frontends. Okay, so here you'll find all my coordinates. And if you want, follow me on Twitter so that we can keep a bit in contact. So thanks for having me. And if there are any questions, feel free to ask them now.
Okay, thank you, Manfred. So yeah, it was a nice presentation. So we have a couple questions that first of all, so how it is easy to migrate for the Angular 7 application to Angular 9 or Angular 10?
Yeah, so in general, without module federation, or do you also think about module federation?
So without the module federation.
Yeah, so in general, it's not that hard. You know, the devil is always in the details, but in general, it's not that hard because we have ng update, and ng update is doing the job for you. I would recommend you to update step by step. First of all, do an ng update to version 8, and then do an ng update to version 9, and then do an update to version 10. In theory, you could do a big bang update, but I found out that the tooling is working better if you do the update step by step, especially if you also have to update other libraries like ngrx or rx, nx. I just did it. It's a funny question. I just did it this week, and we had a hard time because we migrated Big Bang in a Big Bang fashion to the newest version. After that, we decided to go step by step, and this really worked well.
Okay, thank you. So how easy or complex it is to create a service between multiple micro front-end?
Yeah, so you need to communicate sometimes between micro frontends. That's true. And this is somehow a funny requirement because on the one side, we want to have isolation. We want to be independent. And on the other side, we want to communicate between micro frontends. But every time we need to communicate, we are not independent. We are not self-contained. And that means you have to find the sweet spot between those two extremiters. And one sweet spot would be to communicate as much as necessary, but also as less as possible. In general, you want to limit your communication to a minimum. And if you ask me how to do it, you can just use a shared service. Just provide a service and you can then get hold of it on both sides. That's all.
Okay, thank you. So we have a last question. So just as you told about the micro front end, so just micro front end modulation. So it is just like a concept of microservices. So making into each every pieces of the module. So
yeah. Okay. So ideally it's the same, and ideally you have the same vertical cuts, because in an ideal world you have per domain one micro front end and one micro backend, one microservice. And if this works, you are lucky, because then you have less complexity. Each front end is only talking to one backend, and the backends are, for instance, talking with each other by the means of message queues or REST services. But I've also seen that's not always possible. Sometimes your perspective in the backend is a different one than the user's perspective. Think about a typical shop selling ice cream. You have a different perspective from the customer side than from the vendor side. From the customer side, you only see this tiny facade, you give them some money, you get ice cream. But from the back business side, from the back office side, or from the back end side, you have a lot of processes to coordinate. There is a purchase domain, there is a pricing domain, there is a marketing domain, there is a production domain, there is a selling domain. And so it might be that there are just different perspectives. And yeah, then you cannot go with the same vertical cut for the backend and the front end.
Okay, thank you. Yeah, so it was nice presentation, and hopefully the attendee has got lots of information about the modular federation on the topics on the micro-int revolution. So thank you, Manfred, for coming on techWebinarNepal Series 21. Thanks a lot.
I thank you. Thanks for having me, and have a nice day.